Hi, my name is Nilon Joshampole, and I'm bringing you this lecture on SQL Server 2008. It's full text search engine. So what is the full text search engine? The full text search engine is an engine that comes with SQL Server 2008 that is built into the database. It allows for the quicker search of character-based rows for a sort of abstract search. So it's sort of like it'll allow you to iterate through character columns and look for particular word matches, sort of like a search engine, in a quick manner. It has additional properties which allow it to have other benefits. For example, it has a thesaurus built into it. So if you have words that have the same meaning but are spelled totally differently, like good and beautiful, they have sort of a link together, although they have different spellings totally. It will see these commonalities between the words and it will return abstract matches. So look at the meaning of a sentence you entered and it'll return abstract matches based on that abstract concept. This is just one of its many features, which I will get into later. So as of SQL Server 2008, it is actually built into the database engine, but prior to 2008, it came separately from the engine. What I mean by this is that since it was a separate external engine, it tended to be slower, and actually not slower, but it just tended to, they say that by attaching it and embedding it in the actual SQL Server 2008 database, it has the capacity to be quicker than the 2005 external search engine. There are other alternatives that come externally to SQL Server, like Lucient and other third-party tools that have offered alternate solutions, but this that some forms say may work better than SQL Server's built-in full text engine. However, I have never used them, and this is solely based on SQL Server. This lecture is based on SQL Server's full text engine. So basically, this full text engine allows you to search through characters and words in a large amount of data faster. So you might have heard of the like operator, which I will talk about a little bit later. The full text engine tends to work faster than the like operator when there's a lot of data, theoretically. However, that could be questioned based on certain tests I performed, which I'll go into later. When don't you want to use the full text engine? My suggestion is don't use it when you're looking for exact matches, because the full text engine is sort of a fuzzy match, so exact matches will always be faster than a fuzzy match. You want to use it when there's a degree of uncertainty. Okay, so what does it take to implement a full text engine? First, you must have a catalog. As of 2008, a catalog is an abstract concept. Catalogs contain indexes, and indexes are actual physical entities, not logical like catalogs, in 2008. And they could have their own separate file group. I have heard, although I haven't tried it personally, that giving the index, the full text index, a separate partition and storing it on a different disk might cause performance increases, which is always good. However, I haven't tried that myself. But I have tried other things. You must have a full text engine index on each of the tables that you want and columns you want to be searched. The structure of how you set it up is very important when it comes to performance. I will get into different structure methods later on when I talk about speedups, and I will discuss the one that worked best for me. There are different operators that can be used with the full text engine. However, in order to use these operators, you need to have a full text index on that particular column, which you will use Some of the operators are the free text operator, which uses the thesaurus, and you could enter actual sentences and compare it against sentences. And then you have the contains. The contains works on a word by word basis. So you could only have one word which you enter in the contains statement, and each of the separate words that you're comparing to your column must be separated by ors or ands. The free text and the contains operator must go in the where clause. And then in the for from clause, you can have the free text table and the contains table operators. What these do is, based on what you're looking for, they will return based on what you're looking for, they're going to return a rank based on the similarity and matches in another table that you are looking at. And what will happen with this rank is that it will say how close of a match to what you were looking for, the different rows and in that column from that table match up. So in general, what I found most useful was using the free text and the contains operators. However, between the two, I found the contains operator to be the most powerful because it allows more you to center in on what you're looking for and allows more flexibility. The free text operator in the where clause tends to be a little bit more unpredictable. And using it in the from clause doesn't allow you to use hints. So I didn't like that either. So using free text table and joining on a free text table operator will make it a bit more complicated. So let me give you examples of where these are used. Actually, I'll give you examples later in the presentation. Okay, also it's cleaner. So as you can see, if you look at the commented out code, this is lookup based on a like. As you can see, it's going at all the columns. You had to enter the is null on the columns like, and you're doing repeated operations on the same columns looking for different words. It just doesn't seem that optimized, in addition to being slower. However, when you use the free text engine, it seems a bit cleaner. I just liked how clean it was, since you could enter more than one column in brackets and compare it against your string or the word you were looking for. In this case, I used free text as an example. However, I don't recommend using the free text operator. However, you will have to read up on it and determine it to your best discretion. Always look up what you hear. Don't just rely on a person's word, even mine. Okay, so the best implementation that I have found is the one table approach because of performance statistics that I'll explain later. So if you're searching through full text indexes on multiple tables, I found it tended to be slower when you did use the full text engine on joins. So what I suggest is using it on multiple tables, taking the columns on multiple tables and joining them into a single column and just performing the full text search on one table with the actual words joined together. It just seems to perform faster for some reason. What is it and why is it useful? Although I explained a bit of it previously, theoretically it could result in a great speed up if implemented correctly. Its benefits are speeds, simplicity, thesaurus for matching, and it puts less stress on the database than the like, theoretically. Okay, so now I ran proofs of concepts, right? This was kind of funny. So this is the same query. All the queries that I'm showing now are the same queries run on one table. So here I'm using AdventureWorks as an example database, and I was looking at the pc.firstname like Joe. As you can see, I'm looking for any word in first name that has Joe, in last name that has Joe in it, or the middle name that has Joe in it. And when I ran that query, it took 396 milliseconds in total when using the like operator. When I did the same query using the contains operator, it took 29 milliseconds. This was on one single table. If you think about it, that is a massive increase. That is over 10 times. That's saying that the contains operator is over 10 times the speed of the like operator, which is amazing. However, I decided to try it with the other operators to see if they ran the same as the contains. I used the free text, and it took 30 milliseconds. So it was about the same as the contains, giving that this performance speed might vary by a millisecond or two. But the contains and free text seem to work at the same speed for a simple word. However, when I used it on multiple tables, this is what happened. When I used it, the like, which is shown at the top, versus the contains, which is shown at the bottom. For the like, it took, here I'm joining on multiple tables. So I'm joining human resources.employee to human resources.employee address. And then I'm performing the search on multiple tables. So when I performed it on multiple tables with the like operator, it took me a total of, it was about a half a second using the like operator. However, when I did it using the with the two tables using the contains operator, it took me almost 10 seconds. So as you can see, it was a slowdown while it should have been a speed up. What is going on, right? Here again, I used the free text, and it still took around 9 seconds instead of the contains. So I also did a results comparison, and I saw that the full text engine tends to on occasion return different results from the like operator. However, later on I found out it was because I didn't put the semicolons, a star after Joe, and another semicolon. So it has to actually be structured a bit differently. So as you can see, as I'm going to type up now, when you are entering using the contains operator, you want to do contains, the column you're searching, column searching. Then with your string that you're searching against, I should have done this. So as you can see, there's the start of the word, there's a there's the semi double annotation. Then you have the star operator, which is like a wildcard, which must come after the word. Then another double annotation, and then the end of the string, right? So when you're doing a contains and searching a column, you have to use that. Another thing I noticed about using the contains is that when using a word like this, and if your column contained a string like Joe, Suf, and Anne, this string would actually match up against Joe and Joseph. So it'll actually find it in Joe and Joseph. It's not going to only look at the beginning of the string you're comparing against in your column. So this is a column. Column searching equals that. So Joe would compare against that. So the contains would also find a match if your column searched was like Anne, Joseph, Anne. It would find a match here. So that would still be a match, even though the entire string didn't start with Joe. That caused a little bit of complication for me for a while before I realized that. Okay, so now let's continue with the slides. Okay, so I believe here I was looking into it, but the mystery behind that was sort of resolved. Okay, so there are some methods I read about to speed it up, but I never could use because I'm using a left join indexed. You could put a full text engine on an indexed view. However, indexed views have a restriction where you need all inner joins or it won't work. And I couldn't do that because I needed to use a left join, right? Also, to keep the full text engine in a separate file group. I mentioned that earlier. Also, there's a bug in that a patch was released for. So in some cases, using doing the following with the full text engine using contains operators, which is basically every operations, which is basically all the operations you should do, or contains operations. This could cause a slowdown. So there's a patch, even if it was used on the same table. So there was a patch released to fix this. That it's not just restricted to contains. It was also it also included the free text operators, or any combination of the two. If there was an or in between the two, it would cause problems. So Microsoft released a patch for dealing with that. Okay, and what are some bugs and limitations of the SQL Server 2008 this full text engine? It tends to work worse with the OR operations. The CU4 patch, which I showed the link route down here, is what was released to fix it. The full text parameters do not accept functions like is, null, and concatenate. That's not that's just the limitation, but you can't use it inside the actual contains. So the following is illegal. You can't use is, null, Joe, comma, this within the contains operator. You have to use, if you're going to do any operations, it has to be specific to the full text engine within here. So a lot of the operators, I believe, is near is one of them you could use within, right? It wouldn't go inside here, it would go outside here. Near is there's certain operators that you could use in here, or wait, it would have to be used within here. You can't use it outside. You can't even use is, null over here, right? Just so that you know. And what else can I tell you about the full text engine? There's more to read about the full text engine. I found on occasion that the likes actually work faster than the full text. I can't explain why, right? But with a lot of data, sometimes with multiple tables, as you saw in the results, like does work faster. The final approach that I used to implement it was to concatenate the columns together from different tables and put them in one column with a job or handling it in the front end, and keep continuously update these this one row that contained the combination of all the rows. I've also heard that using Lucent.net tends to work faster, and other third-party tools. However, there might be a way to get it working, and feel free to contribute more. Some people tend to use it successfully. However, with large amounts of data. However, I found it was a bit buggy. Oh, and if you don't have the patch installed, another way to get around the slowdown from using the OR operator, right? Contains or contains. The slowdown was to use union operations in your where clause. So you'd use two separate select statements. I know this is not correct, but just get the theory out of this. From table name, union, and another select that would compensate for the and condition or get the other results that you wanted. And that is all for this lecture on the full text engine. I hope it was productive and helped you. And that is all for now. Thank you and goodbye.